Good evening, dear students. Now, discussing about capacitor and the grouping of capacitors. In our previous lecture, we discussed something related to redistribution of charge when the capacitors they are joined together. Okay, and the situation was something like this, and we have got this particular information. Okay, when two capacitors C1 and C2 charge till potential difference V1 and V2 are joined together, they achieve a common potential by redistributing the charges, and the value of common potential is this. Now let's concentrate in energy. Okay, energy of this capacitor system. Okay, when we have two capacitors like this, one C1 another C2, charged till potential difference V1, potential difference V2, both are joined together. After joining together, they have undergone a redistribution of charge according to situation. Okay, and achieved a common potential across both the capacitors. Now, during this process of balancing of potential, achieving of common potential, what is happening to energy of the capacitor system? Let's study that now. This is the situation. Okay, now initially when our system is like this, how much energy the system is having, let us see. Energy initially, let's u1 is equal to half c1 v1 square. You all must be aware of. Now energy in the second capacitor, half c2 v2 square. Done. Now energy initially with the system, this is e1 is equal to u1 plus u2, that is half c1 v1 square plus half c2 v2 square. This is the energy which the system capacitor system have when they both are existing separately. Okay, now these both are joined together to achieve a common potential. Now energy of the capacitor system. Now this first capacitor, small u assume कर लेते हैं, u1 energy of the first capacitor will be half c1 v square. Okay, now energy of the second capacitor, half C2V square. Total energy of the system after joining them together, capacitor system I am talking of, E2 is equal to half C1V square plus half C2V square. Okay, now we have to concentrate in this energy, and we have to achieve this particular thing. Okay, this energy is greater or this is greater, mean during this process of redistribution of charges, the energy is lost by the system or is gained by the system. Okay, so how I am progressing, let's take this term, consider this term E1 minus E2. Okay, now E1 minus E2, half C1 V1 square plus half C2 V2 square. This is your initial energy minus this half C1 V square plus half C2 V square. Okay, now taking this half out and taking this negative inside the bracket, we are getting this term. ठीक है, माइनस कॉमन C1 C2 VV all common, तो V square outside and this. Okay, this is our E1 minus E2. Now, as we know the value of common potential, okay, V is equal to C1 V1 C2 V2 over C1 plus C2 for this situation. Okay, now placing value of common potential in this equation. So equation number 1. Okay, let's place the value. Common potential placed. Okay, and square, common potential square, and this bracket close. Hope this is clear. Now one term will go and the remaining thing will be only single power of C1 plus C2. Fine. This like this. Single power of C1 plus C2 is gone from. Okay. Now taking LCM and solving it. We get like this. C1 V1 square, okay, is multiplied. This multiplied with LCM, okay, and then this is, and then like this. Now what I'll do will be opening these brackets. Solving, we get a thing of this type. Okay, this all and plus this term. Negative also is taken inside. अब यहाँ पे कैंसिलेशंस देखो किस किस टर्म का हो रहा है. C1 V1 square, C1 V1 square, C2 V2 square, C2 V2 square. Now only this term and this term is remaining. Okay, so in bracket we are getting C1 C2 V1 square plus C1 C2 V2 square. Okay, and this last term plus 2 C1 C2 and V1 V2. Okay, C1 C2 also we are taking, we will in next step we will be taking it out, 2 C1 plus C2. Now C1 C2 overall is okay, common, take it out. Now this was the minus sign. Okay, by mistake I wrote here plus. Okay, now this is minus, this is minus, so this will be minus, and here C1 C2 gone out and we are getting V1 square V2 square and minus 2 V1 V2. This is the thing we are getting. Okay, this is your E1 minus E2. Now if you concentrate here, this is V1 square V2 square 2 V1 V2. So this is V1 minus V2 whole square. So solving this, we are getting E1 minus E2. Energy difference in the situation, this or V1 minus whole square. Now you just concentrate in this term. Capacities are always positive. So this part positive. Now V1 minus V2. If V1 greater than V2, positive square. If V2 greater than V1, negative square. Always it will be positive. Mean E1 minus E2 is always positive. E1 minus E2 is always positive. Always positive mean E1 greater than E2. Mean in this process of sharing of charges, the capacitor system is losing the energy. यहाँ energy E1 था, यहाँ E2. E1 greater than E2. It means here the system was having energy more and here it is having less. So where the energy is gone? Now that energy is gone. जब ये चार्जेस रिडिस्ट्रीब्यूट कर रहे थे तो यहाँ पे लीड्स के अंदर फ्लो करेंगे या नहीं करेंगे? लीड्स के अंदर फ्लो करेंगे तो फॉर द शॉर्ट टाइम दे विल बी मेकिंग सम करंट, और जब ये करंट इन लीड्स में से, इन वायर्स में से पास करेगा, ओके, तो क्या करेगा, हीट एनर्जी बनाएगा, है ना. करंट पासिस थ्रू एनी वायर, तो हीट is produced as per the value of resistance of the wire. Okay, so whatever energy is lost here, this basically is delta E, energy lost. Energy lost. Energy lost is delta E, and that is equal to C1 C2 over 2 C1 plus C2 and this V1 minus V2 whole square. Now this energy basically is lost in the form of heat. Okay, और ये हीट कहाँ पे बन रहा है, उन लीड्स के अंदर बन रहा है, उन वायर्स के अंदर बन रहा है जहां पे तुम्हारा सिस्टम जो आपके कैपेसिटर्स को कनेक्ट कर रही है. तो व्हाट वी हैव गॉट हियर, ओके, कि the system loses energy in the form of heat, okay, when two capacitors are joined together. You can solve this particular thing for 2 3 4 5 so on, as many capacitors joined in parallel. They have to be joined like this parallel. Okay, hope this is clear. Thank you. Have a nice day.